Everybody, this is Mr. Yo doing another episode of Yo at Home. Hope you're all doing great. We're talking about groundwater today, and I've made a little diagram here. This would be the surface of the earth in some location, a cross-sectional view. And as it rains upon this surface, the water will infiltrate. That means to pass into the surface. Now, what doesn't infiltrate will run off. And that's what happens when we have a big storm and the streams and everything fill up. That water has come from the storm and it's running off. It's gone. But some of the water infiltrates, if it can, and it seeps down and will fill up all the pore spaces in the rock. Rock very often has pore spaces in it, air spaces, unless it's filled with water. So this rock is permeable, meaning it allows water to pass through, and the rock is also porous. Right? Porous means that there's pore spaces in the rock. It's open so the rock can hold water. So this is porous rock holding water, and it will fill up, and the surface of this zone of saturation, where all the pore spaces are filled, the surface of it is known as the water table. That's the surface of the zone of saturation. So it roughly follows the terrain of the ground you're over. So take a look at this. So it comes up here, and look at the ground goes down so much right here, it intersects with the water table. And what do you have? You have a spring. Right down here, it almost would also be a spring, but it doesn't quite intersect with it. Well, what happens if you get a ton of rain? So then you'll get an occasional spring here. But this spring seems like it's probably a little bit more permanent. It might run all year long. So this also gives an idea, a really good idea, of why this stream always runs. I used to wonder, how can a stream keep running if it hasn't rained for ages? Where's it getting its water? This explains that. This water is gently moving in this direction, slowly but surely. So if there's no rain for a long time, this water keeps coming down and filling that permanent stream, so that permanent stream will continue moving. Why does this water stay here? Why doesn't it leak all the way down into the earth? Well, sooner or later you're going to get to an impermeable rock layer. That might be igneous rock, might be metamorphic rock, but even an area like we live in, where it's all sedimentary rock on the surface, if you reach way down underneath, you're going to find things like granite and other rocks that will not allow water to pass through. So this water then sits right there. The zone of saturation will fill up and keep the water table up pretty high. So that's the big idea of it. There's one little other thing which is not such a big deal, but sometimes it is. Capillarity. That's the stickiness of water is drawn up. The water is drawn up in some of the sediments here. So as you have a tree growing there, and its roots are growing, right? This tree, if it could get a root down and hit the zone of capillarity, this will always have, or most of the time, have some water coming to it. So if it could get a root all the way down into the water table, woohoo, that's really good for it. But if it could get one at least into the zone of capillarity, it will have something to drink most of the time. So this is the idea of groundwater. Now, we use groundwater in our houses. So if this is a house here, well, we will take, here's the water table, we will drill down, not just to the water table, but drill down below the water table. So this all acts as reserve. So that reserve then is water on hand. So if you do the dishes or the laundry or something and you need a whole bunch of water, it's going to draw down this reserve, but hopefully you'll still have enough to keep running, and the water will continuously trickle in. But because the water is always trickling in, you get a depression in the water table called a cone of depression. You can imagine if you use too much wet water from this ordinary well, your cone of depression might reach all the way to the bottom, and you are out of water and quite out of luck. That's a bad time. But a typical ordinary well is drilled down far enough so it has enough reserve to give you water for as long as you want. The other thing to be aware of is your septic system also lies in the ground, and the water leaks out from the septic system, and it's heading towards the water table. So is that bad? Well, if you were to put, say, another well right here, yeah, that might be bad. You might be leaking some of this stuff directly into this and contaminating your water. But you're not going to have a well drilled right next to somebody else's septic system. That would just be silly. Problem that can occasionally happen is that cracks that are existing in the ground can communicate this water directly into a well. When you buy a house, you must have your well tested. The bank requires, if they're giving you a loan, that you have your well tested to make sure you're not getting any water from a septic system that's already there. There does not need to be a huge amount of space, usually. This water just passing into the ground, the bacteria in the ground will break this down and make this water perfectly fine to be added to the water table and eventually drunk. This is not going to hurt anybody as long as it has a good amount of ground to pass through. Again, the bacteria really clean this up very nicely. So we have a septic system, we have an ordinary well. We need to keep those things away from each other, and we need to have healthy septic systems that do not contaminate our water table, because our water table, that is our source of drinking water. Thanks for watching.